Good morning, students. Today we will solve some problems of your NCERT exercise. One of the problem is prove that tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 is equal to pi by 4. Now the day before yesterday we have learned a formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So you can see that this this problem is in the form of this formula. So we'll just solve this problem by using this formula. First two part we'll solve as tan inverse x plus tan inverse y. We got tan inverse 1 upon 5 plus 1 upon 7 upon 1 minus 1 upon 5 into 1 upon 7. Now the last part same we will do as tan inverse 1 upon 3 plus tan 1 upon 8 upon 1 minus 1 upon 3 into 1 upon 8. Now on solving this we'll get tan inverse 7 plus 5 upon 35 minus 1 and plus tan inverse 8 plus 3 upon 24 minus 1. It becomes tan inverse 6 upon 17 plus tan inverse 11 upon 23 on adding. Again this is in the form of tan inverse x plus tan inverse y, so we will apply this formula again. Tan inverse 6 upon 17 plus 11 upon 23 upon 1 minus 6 upon 17 into 11 upon 23. On solving this we got tan inverse 325 upon 325, that cancelled out, that comes 1. Now we know that the value of 1 is 10 at the point 10 is pi by 4, so we put it the value of 1 as 10 pi by 4. So tan inverse or 10 get cancelled out, we got pi by 4 only. In similar case we'll solve one more problem. We have proved that sin inverse 8 upon 17 plus sin inverse 3 upon 5 is equal to tan inverse 72 upon 36. Now as you can see that the left hand side of this problem is either in the sin inverse, and we have to prove that in the form of tan inverse. So first we will convert sin inverse in tan inverse. So yesterday I told you how you will convert one inverse trigonometrical function into another trigonometrical function, inverse trigonometrical function. So first we will put this sin inverse 8 upon 17 as theta. Sin will go to the right side, so that becomes sin theta is equal to 8 upon 17. Now we'll make a triangle, right angle triangle, putting one angle as theta. So we have sin theta is equal to perpendicular upon hypotenuse. So we put it the value of 8 as perpendicular and 17 as hypotenuse. On solving the PGT, Pythagoras theorem, we got the base as 15. So tan theta is perpendicular upon base, so we got tan theta is equal to 8 upon 15. So theta is equal to tan inverse 8 upon 15. Now similarly we can convert sin inverse 3 upon 5 in tan inverse, that will come tan inverse 3 upon 4. Now our left hand side become, in place of sin inverse 8 upon 17 we can put the value of sin inverse in tan inverse, that is tan inverse 8 upon 15, and sin inverse 3 upon 5 become tan inverse 3 upon 4. Now we can apply the same formula as I told in the previous question. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. We got this value tan inverse 8 by 15 plus 3 by 4 upon 1 minus 8 by 15 into 3 by 4. On solving this we got tan inverse 32 plus 45 upon 60 minus 24, which is tan inverse 77 upon tan inverse 77 upon 36, so that is our right hand side. It is 77 upon 36, so which is our right hand side. And in this way we can solve more and more problems of this inverse trigonometric function. Thank you so much.